given this problem statement, so it says that let L, so L is not equal to 0, and this belongs to the set of real numbers. That means L belongs to the set of real numbers except 0. Now, if A and B are the roots of the given quadratic equation, that is x square minus x plus 2 times L, that is equal to 0, and here A and G are the roots of the equation, that is 3 times x square minus 10 times x plus 27 times L, that is equal to 0. So in that case, we need to compute the value of B times G over L, right? Now, proceeding towards the solution, so here it is given that A, right, this A is a common root of the given quadratic equations, right? So one of the equation is x square minus x plus 2 times L, that is equal to 0, and the other one is 3 times x square minus 10x plus 27 times L, that is equal to 0. Now, it is well known fact that if you consider this equation, that is x square minus x plus 2L, so let me write it here actually, and this equation, so what I will do here, definitely this variable A is something which is going to satisfy this one, because it is given that A is the root for the first quadratic equation, as well as for the second quadratic equation. So here instead of x, I will substitute A, so that becomes 3 times A square 10 times A, right? And here in place of x, again A square minus A plus 2 times L, that is equal to 0. Now, in order to perform manipulation successfully on this one, so you can observe here we have 3 times A square. So in order to eliminate this A square, what I will do, in this given equation, I will be multiplying 3 on both the sides. So that further results in 3 times A square minus 3 times A, and 3 2 is 6, 6 times L, that is equal to 0. Now, I will perform the subtraction operation. So here this is subtraction. Now, on performing the subtraction operation, so this 3A square positive and negative 3 square, this becomes 0, and this becomes 7 times A plus 21 times L, that is equal to 0. And from this we can mention that A is equal to 3 times L, right? Now, finally we can say, so this equation over here, that is 9 times L square, right, plus 3 times L plus, so this would be negative, right, because here I am using the value of L over here, right? Now 3 times L plus 2 times L, that is equal to 0. So because this A is equal to 3L, so I am using this value of A in this particular equation, right? So that becomes, so instead of A, I'll substitute this 3 times L. So that effectively becomes 9 times L square minus 3 times L, because again instead of this, so what I'm doing exactly, let me just mention here, right? Let me just mention this part over here. So using this, okay, using the value of A equals 3 times L in this equation, that is this particular equation. So I'm getting this one, right? If there is any doubt regarding this one. Now, after the substitution here, we can definitely extract the value of L over here, right? So this is a quadratic, and on solving this one, I'll be getting L equals 1 over 9. So if that is the case, now here the value of L is not considered 0. Reason being, why the other root is rejected, because L, if you observe, because it is already mentioned in the problem statement that L cannot be 0. So since L cannot be equal to 0, so therefore only one value is accepted, right? So from this, if it is given, if it is already established that L equals 1 over 9, so from here we can clearly mention that A is equal to 3 times L, right? So from this we can say A is equal to 3 times L. So here value of L is 1 over 9, right? So value of L is nothing but it is 1 over 9, right? So from this we can say that A is clearly equals 1 over 3. Now if we take the product of roots, if I take the product of roots, let's say that is a times b, let us say, correct. So here instead of a, so from this one we can say that product of this roots is nothing but 2 times l, right. And this one further implies that b is equal to 2 times l over a, and from this we can say that b, or we can say this is equal to, so this instead of l we can replace this with 1 over 9. So this l value is 1 over 9, so this will get replaced with 1 over 9. Let me write in parenthesis, and the value of a is 1 over 3, so let me replace it via 1 over 3, so that effectively becomes 2 over 3. So this is the product of a and b. And now if I check for a times g, so for a times g, that is a and g are the roots of this equation actually, 3x square minus 10x plus 27l, that is equal to 0. So a times g can be written here as 9 times of l, 9 times of l, if you observe this equation, right. Yes, so this one can be written as 9 times of l, right. So this further, from this we can write further that g is equal to 9 times l over a. And if I substitute the values now, so instead of l I'll substitute, so this entire remains the same, only the thing is that l over a remains the same, only the thing is that here I'll put 9. So this effectively becomes now 3, right. So we got the value of this product of this, that is a times g as well, right. So finally the quantity that has been demanded here, so now we have the values, we can easily substitute the values and you can get the answer. So therefore this quantity, that is, so this will be equal to b. So b times, what is the value of b here? So b will be 2 over 3 times a, right. So b can be written as, instead of this b I'll write 2 over 3, 2 over 3 times a, 2 over 3 times, let me just, times a, correct. And this g can be written as, here a times g is actually 3, so this a times g we can replace it by 3 later, right. And the value of l is 1 over 9, the value of n is 1 over 9, that is 9 to the power minus 1. Now if you can observe this clearly, if I rearrange the term, so this can be written as a times g, and a times g can be replaced by 3. So effectively this 3 and 3 gets cancelled out, so that is nothing but 2 here. So now here 9, so at this part we are having 2, so 2 over 1 over 9, so that becomes 9 times 2, that is 18. So finally for this expression 18 is the answer, right. So on resolving each of this, 18 is the correct answer for this particular problem statement.